The focus of this video is to define what a polyatomic non-acid ionic compound is, distinguish between the two types of ionic compounds, type 1, type 2, recognize the 7 variations of these ionic compounds, and identify where the anions come from. Before we look at the 7 different variations, what exactly is a polyatomic non-acid ionic compound? Well, that is a compound that is formed by the ionic attraction between opposite charges, meaning it will contain a cation plus an anion, or in simplest terms, a positive and a negative charge. Now that we know what these compounds are made of, when we see a polyatomic ion, how should we treat it when naming the compound? The answer to that is that we treat the entire polyatomic ion as one group with one overall charge. To make that idea clear, if we look at this anion, what does it represent? It represents one phosphate ion with an overall charge of 3 minus. Now that we understand how to treat a polyatomic ion as one unit with one charge, the next question is, where do the anions come from? Where does this part come from, the anions? Well, there are 3 main ways we can identify or derive the anion: from the 9 common polyatomic acids, from the memory polyatomic ions, or from a single nonmetal ion, also known as a monatomic anion, that will be found in the periodic table. Now, let's take a closer look at the first method, the 9 common polyatomic acids, also known as ic acids. By learning the 9 common polyatomic acids, which, by the way, they include carbonic, acidic, chromic, nitric, sulfuric, phosphoric, bromic, iotic, and chloric, you will be able to determine multiple anions. Let's take, for example, bromic acid. When bromic acid donates its hydrogen ion, it reveals its bromate anion. You take this H off, you're left with BrO3 minus, which is its anion. The pathway shown here basically demonstrates how these acids can be used to determine their corresponding anions, and also is going to be able to help you find other family acids. In a different video, I will demonstrate how to use this pathway to determine other acids in polyatomic anions. In the meantime, keep the 9 common polyatomic acids in mind. Now that we have looked at the 9 common polyatomic acids, and you have a basic idea of how to determine their anions, let's move on to the second way we can identify anions. This is what I call the memory polyatomic ions. These are polyatomic ions that you should know and remember. The ion formulas and charges are listed here in column 2. So this is the column I want you to focus on. Starting in the bottom, we have permanganate, dichromate, dihydrogen phosphate, hydrogen phosphate, hydrogen sulfide, hydrogen sulfate, also known as bisulfate, bicarbonate, also known as hydrogen carbonate, azide, cyanide, azetate, hydroxide, peroxide, and ammonium being the only cation in this list, meaning with a plus charge, with a positive charge. By the way, notice that some of these ions also have relative acid listed in column number 4. When the relative acid is provided, we can use the acid formula to help determine the anion by removing the hydrogen ion. Let's take, for example, hydrocyanic acid. When hydrocyanic acid donates its hydrogen ion, the anion is revealed, Cn minus. You remove the H and you get its anion. The same thing with the next acid. You remove its H, where it donates its hydrogen ion, and it becomes N3 minus. And that's how it gains its charge, by donating one hydrogen. The same thing here. It donated only one hydrogen. Going further down, when we look at dichromic acid, when it donates both of its hydrogen ions, we get its anion, which is dichromate. The important thing to remember is that you should still memorize the polyatomic ions from column 2. Finally, let's look at the third method for identifying the anion, which is using the periodic table. The groups on the periodic table, also known as columns, can help us determine the common charges of single nonmetal anions. In general, group number 14 is a special case because carbon can form a 4- charge when it forms an ionic carbide. Group number 15 forms a 3- charge. Group number 16 forms a 2- charge. And group number 17 forms a 1- charge. Now that we have covered the 3 ways to identify the anion, let's look at the other ion in the compound, which is the cation. So, what do we need to determine about the cation? We need to determine whether the compound is a type 1 or a type 2. So what makes a type 1 different from a type 2? Remember that a type 1 has a fixed charge cation, and that cation can be a fixed charge metal coming from column 1, column 2, or the 6-pack. However, the cation can also be ammonium with a 1+ charge, especially ammonium, since we're talking about polyatomic non-acid ionic compounds. Since the cation combines with an anion, the anions for a polyatomic non-acid ionic compound can combine with any of the categories seen in this box. In contrast, a type 2 has a multiple charge metal. It also includes a cation plus an anion. But the difference is that it has a multiple charge metal, meaning the metal can have more than one possible charge and is found inside the blue area. And that cation will combine not with a single nonmetal, but instead with any of the categories that you see here in this box that has to do with a polyatomic anion. Now that we have the two types established, how are the naming rules organized for the polyatomic non-acid ionic compounds? Well, for type 1, there's one set of rules for going from a formula to a name, and one set of rules for going from a name to a formula. For a type 2 ionic compounds, there's also one set of rules for going from a formula to a name and one set of rules for going from a name to a formula. So between type 1 and type 2, we have 4 sets of naming rules in total. With these 4 sets of naming rules in place, how many variations of polyatomic non-acid ionic compounds are shown in this chart? And of course, the answer to that is 7 variations in total. 5 come from type 1 and 2 come from type 2. So in summary, to work with a polyatomic non-acid ionic compound, you need to know which type of compound you have, either a type 1 or a type 2 compound, so you can determine the type of cation that it has. You also need to remember 3 important factors, which include the 9 common polyatomic acids, also known as ic acids, the memory polyatomic ions, and the single non-metal ions from the periodic table, so you can derive or identify the anion. Finally, you need to remember that the polyatomic ion is treated as one group with one overall charge.